recording. Let's continue. Yeah. So so I'll still have this button here. Um, and then what you need to do is you almost need to like, doesn't matter what it is that you're doing within your Rhino file, you need to create almost like a shader palette. Okay, so just like to the side of your model that you don't see, just build a few cubes, or it can be spheres. It can be really whatever you want, and I'll just copy these over like 3 times. Okay, and then I'll come in here. So these are almost like your material samples. Okay, and I'll come in here. I'll go custom. Uh, okay, one is custom, and then I'll go import from material library. I'll just bring in like a word. See, I don't know what word this is, but we'll find out. And I will also bring in, let's say, a metal. Okay, and you could bring in whatever you want. It's just bringing these 3 in, and then I will apply one material to each of these cubes. Okay, so after you've applied your materials, okay, let's just say before I apply it, I'll just remove the materials for now, and you don't have to remove it, just watch what I'm doing. When I have a panel, and I'll go in here, see how it's not picking up anything, even though there's materials in here. And it's because I added them and deleted them, so it's bringing those in as null. So you typically don't delete materials either. Once you've brought them in, you just kind of use the list. But now what I'll do is I'll apply one material each to each of these cuboids. And then when I go back in here, press the button, you'll see how it shows up, right? So you have to apply it first to like a palette inside your model, create a little palette for all the materials that you want, and then it'll show up in this list. And then let's say if I have another cube, this is a big cube, and I want to apply one of these materials to this. So how do I bring in this cube as a geometry? Huh? Yeah, you could use geometry. You could also use brep in this case, but I'll just use geometry. So set one geometry. Now it's set. I can go back into Rhino and hide this because now I have this here. And then what component will I use to preview this geometry, render this geometry? Yes. Okay, this goes into geometry. And then how do I pick one of these items from the material? What component will I use to just pick one of these items? Yeah, list item. So list item will give me the ability to select one item. So I have 5 items in here. My index goes from 0 to 5. How will I build my slider for this to pick the index in list item? Hmm? Yeah, but from which number to which number? 0 to 0 to 5, correct. So it is 6 numbers because 0 is always counted in the list, as you can see. So I'll go 0 to 5. And then I will plug this into material, and this gives me my material. So I'll go into rendered view. Yeah, I am already in rendered view. So you can see with 0 it does nothing because in 0 it's null. I applied a material and I deleted it, so it becomes null. So it's picking up all the materials, and it picks up the history as well of things deleted. And it's kind of it's almost a smart thing, because let's say after metal, if I had a few materials and then I had a few more, and then I delete materials in the middle of the list, it doesn't start shifting the list. It still keeps your numbers intact. So that's why those things come up as null. So this is actually good thinking on the part of the developers. So when I go 1, it'll be null. What do I pick on my number slider to get Zebrano? Yes, that was an easy one, guys. So now you have 4, and then I'm going to hide my thing here, and then here you go. Now you're able to assign materials like this, and then when I go into Arctic view, I actually it's a bit flat, so I'll stay in rendered. Yeah, um, so I can apply this. And then if you want to play with your texture, you come into Zibrano in your material settings, okay, and you can select the material here or the texture file, and then here you can select the size, the mapping. So I can, if I want more resolution, I can actually go like 10 by 10, or I can go maybe 20 by 20. It's not even doing anything. Yeah, so you have to press this button to update. So see, I increased my mapping size. So instead of 0.1 tile by 0.1 tile, I'm saying I want 100 tiles by 100 tiles mapped on my object. Okay, and then once I made that change, I have to come back in here and press this button to refresh it. And I can do the same thing with metal if I want. Okay, any questions on this? So it helps you apply quick materials inside Rhino if you need to do quick, you know, visualizations. You guys get it? Yeah, let's move on. Disable. Huh? What view are you in? Are you in rendered view? Okay, you need to check your settings then in here. A lot of times you have to play with your settings in the display tab. But in a nutshell, that's how it's done. Okay, so let's move on to data trees. Which one shall we start with? Did you guys have a look at that document I sent you by Andrew Human? PDF file? Discord. It's in uh, it's in software. It's this PDF document. Okay, I want you guys to go through this. This is very useful. And the one tutorial we're going to do today is actually built off one of the examples that he talks about in here, like this example here. The entire campus, the buildings, the building levels, and individual spaces, how you go about selecting all of these using data trees. This is very important, guys. Like, you have to be looking at the resources that I share with you, because a lot of times the advice I'll give you, the crits I'll give you, or some of the things you might have to do sometimes will be using this information. Um, these tutorials are actually like, this is a bonus. Data trees at any stage of Grasshopper. So this here, this document is not specific for for let's say like it's not specific to like an exercise or an example. This document explains how data trees work and is using an example as a means to explain that to you. So that's what we'll do. We're going to use architectural language to understand data trees. But this might come in handy. Okay, so let's begin. The first thing I'm going to explain to you guys is how data trees actually work in Grasshopper. Okay, so you guys know what longest list is. Okay, so let's go through it. So we're gonna build a series of points. Okay, so just go into top view, and then let's build a series of points. So we're gonna be learning new components as we go. So let's use the series command. Construct point. So we're gonna use series to construct a series of points. Okay, so you see how it starts to generate these points. So how is it working? It has a start, it has a step, and it has a count. So if I want 9 points, what do I do? Yes, good. So let's go 9. We can leave the others default because they'll stay there, but now I have 9 points going this way. Okay, and then let's copy this over. Then I want another one with 17 points. How do I do that? Huh? Exactly. Come on, guys. Count 17. So now we have 17 points. Okay, so we have these two lists, and what we are going to do is we are going to move one of these. We're going to move one of these over. Yeah, so what we'll do is if we want, let's say if we want to move this one to not overlap this, but we want to move it in the y-axis, what will we do? And it doesn't mean use the move command. Yes, that's right. So we'll feed like a y coordinate. Let's just say 5, for example. Okay, so now we have this. Now I want to draw a line between this set of points and this set of points. What will I use? Huh? I want to draw, no, line. I'm giving you such easy ones, guys. Okay, so see what's happening here? See how from the short list, it's using the last number and it's connecting to all the remaining points. Let's look at why this is happening. So just to let you guys know, this is what's known as the longest list mechanism within Grasshopper. So this is now you're starting to see how Grasshopper works. Okay, so let's plug in a panel to understand these points here. So 8 points, which is this one at the bottom. So that's the short list. And then let's plug in the long point list to this. So by default, what Grasshopper is doing and the way the list management works is because I wanted to build a line between these two, it doesn't have any more points after point number 9 here, or serial number 8. So it just keeps repeating point number, serial number 8, right? So this is what's known as the longest list mechanism in Grasshopper. So this is always how it works. So essentially what you have to do is if you wanted this thing to be intact, you have to have the same number of points in list A, same number of points in list B. Otherwise, you have to know as the operator that this is what's going to happen. So your job is to have data matching happening. If let's say you wanted to use the shortest list, there's a way to do this. Let's see, shortest list. So I can plug in list A, list B, and then let's see what it gives me as adjusted list A and list B. Yeah, so see, I'm using now shortest list, and I have to use a special component for that, where it actually culled or deleted points in the longer list just to match list A. Does everyone understand this? And there's also a component called longest list, but it's almost redundant. Like you guys don't need to use it, but let's just see what happens if we do use it. Let's plug in the first set of points in list A, second set of points in list B, and then I'm going to plug this into the same panel system because I'm forcing it to create a list. So see what happens? It increased the number of points in list A by just repeating the last point again and again to match list B. Okay, but by default, this is what Grasshopper does anyways. But by using longest list, I'm formalizing or I'm actually uh, including in there physically all those points instead of by default making it happen. Okay, so if I take this line component and I use the shortest list to build the line, see how it doesn't use the last set because I'm using the shortest list. So it's going to just match the long list to the short list. But if I use the long list, what will happen? Yes. Exactly, yeah. So look at the panel. So I have list A going into this panel and then here, and then you can see here how it's just repeating, right? It's just getting repeated. Yeah, so by using longest list, you're actually like doing that as an action to create that as part of the list. But even by default, it does that anyways. But by doing this, and when you start applying it, it makes more sense. There are a lot of uses for these kind of things. But this is by default how Grasshopper works. Okay? Make sense to everyone? Okay, next question. Um, next, what do we look at? Let's look at. Okay, so let's very quickly look at basics of data trees. So I'm just going to disable this. Let's create a grid. So I will go, what choices do I have? Hexagonal. 2D grid with hexagonal cells. Okay, and then if I use Control Alt and I click on it, it shows me where it is. And I can go in here and I can select other things also. There's rectangular. Let's select rectangular. Okay, let's go with rectangular grid. So you see how from the top, it's bringing in this plane, it's bringing in cells, it's bringing in points. But what I want the cells. I don't want any of the other noise. So I'm going to use a data component, put the cells in here, and then I'm going to hide or turn the preview off from the grid. So you see now I just have a bunch of, I just have my polylines in here now. So let's look at how these data structures work. We're gonna go, we're gonna use an area command. And when I plug this into area, the area gives me areas of each cell, but it also gives me centroids. Okay, and then what I can do is I can actually put in a point list at each centroid to visualize each cell. Okay, and now we're going to do some manipulations. So currently, does anyone know what this type of wire is called? The wire, this dashed wire. Not all the wires are dashed. Dashed wires mean it's now in a data structure. It's in a list of a list. If it's just a single list, then, and I'll show you what that is. But we're going to use a command here, a new component. It's called, that's how you visualize your data trees. It's called param viewer. It's a beautiful command, and it gives you this window, and you can plug in anything into this to visualize your data structure, to understand the data and how it's structured. So See how right now it's got data with 10 branches. So it's got 505. So can anyone look at this param viewer? So it says n equals 5 and there's 10 branches. And here we have, we're going from like 0 to 4. And then you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 columns, right? Does that make sense? So you have 10 columns, which is what this is, data with 10 branches. 10 branches are your columns. And n equals 5 means you have 5 cells in each branch, which is each column. Okay, so 0, 1, 2, 3, 4. That's 5 cells per branch. Does everyone understand that? And here's a really cool way to visualize it. Double click on your param viewer. This shows you your data tree structure. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 branches, and each branch contains 5 cells, right? So let's go back here. We have 10 branches. Each branch contains 5 cells. And then see here, we have 10 branches, and it's showing you. And the 5 cells, it's contained within each branch. Okay, so if you look here, you see 0, 0, 0, 0, 0, 1, 0, 0, 2, 0, 0, 3. Those are each branch. And then if you come here, you can actually see 0, 0, 0. That's one branch. That's probably this first one on the to the left, this row, this like column of cells. Okay, now let's do some manipulations. So the first thing I'm going to do is I'm going to add or right click on the data and I'm going to say simplify. So what did that do? You see here, I'll remove this, but see how we have 0, 0, 0, 0, 0, 1, 0, 0, 2, 0, 0, 3. When I did simplify, it collapsed them all. It collapsed all the zeros that we didn't need, and it's basically just given me the 10 branches without putting it inside a structure, without putting it in a tree branch. Right? You have to think of it as like a fractal structure. It's like you have a tree, you have a branch, the branch will have 2 more branches, and so on and so forth. But when I use simplify, I get rid of all those branches. And there's uses for this. Okay, we'll go through that. The other one you can look at is flatten. So when you flatten it, everything gets contained into one list. So you see now what happened to your numbers on the right side on your to the cells. See, I'll undo this. But you see how you have 5 cells per column? As soon as I flatten it, it there's no more branches. There's no more cells. It's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's just continuing. It's just one long list with everything contained inside of it. Right? And then let's undo flatten, and then let's go maybe graft. So right now, the way this wire is, it is a grafted wire. So it's already grafted. But if I graft it one more time, what will happen? Can anyone take a guess? You get an extra layer of branches. Exactly. It just creates another list. So let's visualize it. See that? So now you have, like with grafting, it's almost like the cells are, let's just see. Yeah. So it's got data with 50 branches. So all of them have their own thing now. And it's just the nature of how this particular one is working, but it'll get more clear once we get to the next example. Okay, so that's grafting, and then reverse just kind of reverses the list. So I'll undo the graft, and then if I want to reverse it, it's basically instead of starting from the bottom and going up. So you see how you have 0, 1, 2, 3, 4. When I reverse it, it's starting at the top and then coming down. 0, 1, 2, 3, 4. You're just reversing the order. Make sense? Point list. Did you get it? Okay, good. Okay, the other thing I want to look at here is, for the sake of this list, so let's just look at this list. Can I simplify this list a bit more? And if so, what do you think I could do? I already did it once. Just want to see if you guys are following along. Yes, good. Right? So I don't need all those extra branches unless I have to do data matching with another component if that's going to interact with this. I want data structures to always match. You always want data structures to match. It can be one against many, but it can't be many against many. Then, especially if it's just different numbers. And I'll explain how that works as well. But let's just take this and let's turn on control points. Okay, so I'm going to take data and put that into curve, and I'm just turning on all my control points. Okay, and I just want to visualize what's going on here. So I'm going to use param viewer, and because I just want to show you guys like how these lists are being constructed. Right, so what I'm doing now is try to understand this. So for each cell, I'm turning on the control points. So now what this command will do is, if I have one cell, how many control points do I have for one cell? 4, exactly. So each cell will have 4 control points. So what is it going to do? It's going to build a list inside a list, right? So there's going to be a list of cells, and then each cell will have 4 items, which will be control points. So let's visualize that. See? So here's one cell, and then here's 4 control points. 1, 2, 3. 1, 2, 3. Why do I have 5? Huh? Uh, let's see. See what is going on here. I mean, it's doing the right thing. But 0, 0, 1, 250, 5. Okay, this is how you pick items from a tree. You use a tree item. So you have tree, you can create path, and you use construct path for this. Why do we have 5? Sorry? Why would it be 5? Yeah, corners of each cell. Unless it's repeating one for each. Zero 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 one 02 03 04. Yeah, it's repeating the first one again. It's like creating a loop. It's closing up and it's repeating. So let's see if let's see if I'm right. I think let's look at panel. Let's just look at the points. So if we turn on the panel, so let's see for the first one. Yeah, you see 0 and 4 are the same. 0 0 0 1 0 0 1 2 0 0 2 0 0 0 0. Interesting. I never realized that. Okay, but yeah, each has 4. But then you see how it's building the tree, right? That's the main thing about this, is it's become a list of a list. So it went from 0 1 2 3 4 5 6 7 8 9 because I simplified it. It went from that to 0 0 0 1 0 2. It's added another branch, another layer of branches. Is everyone clear on that? So it just created another layer of list. Basics of data trees in Grasshopper. Any questions on it? You can use cull duplicates. There should be, yeah, cull duplicates. Right. That's if you want to or if you need to, I guess. I would do it only if you need to and if it's become like a hindrance with doing something else. So see how it's like culled? So you just cull duplicates to do that. Okay. Let's move on to the final exercise. I want to try and get through this quickly so we can move on. Okay, so we're gonna follow Andrew Human's example here. So basically what he's saying is you should be able to use data structures, and I want you guys to go through this whole thing and it'll become clear. Um, to first build the entire campus, build the buildings, the building levels, and then individual spaces. Okay, so I'm gonna try and recreate that. So the first thing I want you guys to do is build 3 uh, control point curves. So come into Rhino and just kind of build 1, 2, 3. Okay, how am I going to bring these curves into Grasshopper? Yes. And then how do I select all 3 curves into one component? Yes. So right click, select set multiple curves, and then I select, the order matters, okay? So I'll go from left to right. So I'm gonna select the first one, second one, third one, and right click inside Rhino, okay? So now I want to offset each curve in each direction. So I'm going to use the offset curve command. I'm going to put the curves in here, and then you see how each of them are offsetting in one direction only. What do I have to use to also make it offset in the other direction? Negative. Just use a negative component. Um, and then what I will do in here is I also want to be able to specify a value, right? So I'm going to go 0 dot 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 0.05 dot 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 10. Put that into value. Right? So let's say I only put the number slider into distance. It's only going to control it for one, right? If I only put the negative in here, it's going to go in the negative direction, but it's only going to control one. But what I can do here is I'll remove negative. I'll first put in just the number. And remember, order matters. So I put the curves in order, and I'm also going to put the distance in order. So I'll put the distance number slider first, and then I will put the negative slider in there, press shift, and plug this in. It allows you to put multiple things in. But see how nothing is happening, right? Like it's reading weird. It's reading weird. Can you guess what it's doing? See, so I entered number first. Think about the list, the longest list thing. I put number into distance first. Which one do you think this number is affecting? Because I have the first one, exactly. I have two numbers coming in, 5.76 and negative 5.76. But I have three curves going in. So what is negative 5.76 affecting? The negative will affect the last two. So did you what order did you put it in? Are all your curves going in like one direction? Yeah, so the direction of your control curves will also matter. Uh, I'll give you an example. So if I see how on the right side it's pointing right, and these two are also pointing right, I did that deliberately because I just know how they work. But but if I take this one this way, just watch the offset on that first curve. See how it flips? Is just how the direction of the control point curves. That's just how it works. But the question here is, okay, let's just undo this. Take the distance out. When you included the curves, did you go by order, left to right, one, two, three? Okay, and then put the number slider in first, and then put the negative in by pressing shift. So what's going to happen here is number slider will affect the first curve, negative will affect the last two because there's only two numbers coming in, but there's three curves, right? So remember longest list. It's going to just repeat the last number for the last curve. So at this point, I like to um, organize my data a little bit. So I'm going to use a merge command. And I will first put my number slider into data 1, negative into data 2, and then I'll bring merge into distance. But it's still doing the same thing, right? Like it hasn't fixed it yet. So what do you think I could do here? Yes, I could graph the distance. If I graphed the distance, now it starts to offset to both directions by using graphed. See? Just by putting this into a data tree. So let's look at some param viewers here and try to understand this. So let's put the curve in here. See, it's got one branch with three numbers in it because it's just flat. It's just three curves. And then merge param viewer. I'll bring this in. And it's got data with one branch with two numbers. That's why it's affecting it the way it does. But if I use graphed, like I am, graph tree, you can also use a component for graph tree instead of just grafting inside the component and put this in. See how it creates two branches now. So it's got now two branches, one separate for one number and the other one for the other number. And what that does is when it mixes with curve in offset curve, now it's going to create a list, right? So it's got one list here, and it's going to create, can anyone guess how many lists it's going to create? 6, one for each curve, right? So 1, 2, 3, 4, 5, 6. This one? Because it gives you two lists, and then those lists act independently of one another. So remember what I said, multiple with multiple, if it's mismatched, will create issues because of longest list. But one with multiple is doing something. It's making the one thing do what it needs to do to each item in a tree. So I've got two lists, so 0, 0 will affect each curve, and 0, 1 will affect each curve. So positive number is affecting each curve, and negative number is affecting each curve, and it's giving me 6 curves. And if I don't graft it, let's see, it still just gives me 3 curves because it's matching longest list to shortest list. In that case, it's a different scenario. Okay, so I'll graft this again. So this is with this one. Okay, and then the other thing we need to look at is what is the right thing to do? Do you graft distance or do you graft curve? Okay, let's just see what happens if we graft curve. So if we graph curve, it's got one branch, and then each branch contains each curve, right? So 0, 0 in this case is this first control curve, and it's got both offset curves in it. 0, 1 contains this control curve, and it's got both offset curves for it in this case. But if we graft curve, and let's just have a look, see how it's got two lists that contain 3 curves each, right? Because you're using distance, you're using two items, you're using two distances, positive, negative, and it's giving you 6 curves. But what it's doing is it's got two main lists, and each main list contains 3 curves. So for the first, second, and third control curve, it has the positive offset in one list, and it has a negative offset in the other list. Okay, now let's make this clear. Let's because what I want to do is, and I'll tell you why I'm doing this, I want to loft between each offset curve. I want to loft each pair of offset curve. Which one will I use? One list for each control curve, right? So is it this one where each list has 3 curves? Or is it this one? I know this makes your brain go mush, but once you understand it, guys, and I promise you, once you understand it, you guys are gonna be rock stars in Grasshopper. Let's just try to understand this today. Okay, so this when you graph curves, because I'm making, and let's see what that looks like when I graphed curve. It's got three lists for each curve. So when I graphed curve and I multiply it or mix it with these positive and negative values, it's going to it's going to stay within those three control curves. So each control curve will retain, and if you see here, the pair of curves. So can anyone take a guess which graph will I use? Sorry, this one? Okay, let's see what happens. So loft. Between my positive and the negative for each curve. Here, let me show you again. See this? I want to make three different buildings and I want to loft my base floor. So I want to create a surface for my base floor first. So if I put this in, yeah, there's nothing going to happen. And I'll show you why. Let's just have a look. So what's going on in this data tree? Yes, I have a pair, but what's going on? You see how I have this like this layer of zero, right? So I use a command here called trim tree. Okay, so I'm not going to use loft just yet. Let's just use trim tree, but I'm going to loft between them. So when I trim tree and I do again prime view, so always like when I use components which I've never used before, I just hover over them and I read what it's all about. And I try to understand how to use it. So it says reduce the complexity of a tree by merging the outermost branches. Okay, let's see what that looks like. So see how here, why is it not working? Because you have 6 branches and they're data with 6 branches and each branch has one curve. Do you guys see? So I'm not able to use two curves together because each branch has just one curve. So how can I reduce that complexity? I use trim tree, which reduces the complexity of a tree by merging the outermost branches. So now it's given me 3 lists with 2 curves each, one for each control curve. Do you guys think loft will work now? Yes. Okay, and then let's see what happens if we loft distance. Okay, can anyone guess what will happen if we loft with distance? Considering that it gives you 2 lists, one list contains the positive offset of each control curve, negative off, and the other one contains the negative offset of each control curve. It'll go from it'll go from each positive offset, right? So let's have a look. See that? So what is it doing? It's going from, see how it's got data with 2 branches? Because I'm grafting distance and there's only 2 numbers for distance, it's creating data with 2 branches with 3 curves each. So for each control, in the first list, it's picking up the positive offset of each curve. So when I use loft, it's lofting between the positive offset curve of each control curve. See that? You guys, does everyone understand this? This is really important. And then for the second one, it's lofting between each negative offset. So the right one in this case, and we're still at the beginning of this, is curve. Okay, because you want to do data matching. You're manipulating your data, and you can do that by going into all these. You just go into sets up here, and this has all your commands for your trees. Does that make sense? So now let's see what's the next step. So now I want to build. I'm still at the entire campus. So can anyone guess what I need to do next? Sorry, go up and also create floors in the in while doing so. So you extrude. Yeah, you copy in the Z, but what do I use if I want to copy them multiple times by using the same command, not by repeating the move command again and again. Okay, so let's see. Let's see. Move. So now it's starting to come up. Okay, and I know I want to go in the positive direction or Z direction. So I'm using Z, but if I want to move it multiple times by the same floor height again and again, what I can do is I can create a series component. Okay, so now it's going multiple times. And then my start is fine at 0. I don't need to change that. Um, for my step size, let's see. Then count, I can just use something between 0 to 10. So that will tell me how many floors. Um, so now, look at this. So we used a merge command here to have multiple numbers for offset. If I want to have, if I want to control for each of these buildings separately by using the same component and have different number of floors for each building, what do I have to use? Hmm? Graph will be used, yes, but I mean, you're right, draft will be used. So let's just see. Um, yeah, so you need to increase the number of items you put into count, right? So I can have 3 of these because I have 3 buildings. Let's go 7 or, whatever. You guys can pick however many floors you want. And then I can put them in one by one in order into count, right? And then now you can control individually each building because now you're playing with a list. Now uh, you've got like 3 different series being built going into the move command. So let's use merge because I want to keep my data clean. I will bring these 3 items down here. Data 1, data 2, and then automatically it starts going data 3, and I will delete data 4 because I don't want any glitches, and I'll put merge into count. Yeah, just with the negative. Okay, so let's just say, okay, I'll increase my heights. bit, and then I've got all these. Okay, so now we need to subdivide the floors into partitions, into rooms. And I've got all my geometries in there. I'm going to hide my loft component just because I don't want it to show up again and again. Hide my offset curves, trim tree, hide curves. Okay. So now I want to partition it. What can we use to partition or slice up surfaces? We use a command called isotrim. Okay, so you can put in the surface and you can create a domain, right? So it's asking for a domain, u and v value to slice up a surface. So I can make my own domain and I can say divide domain. I'll go with divide domain square. And my geometry goes into domain because that's what I'm dividing up. You see how it starts to slice up. But you see how it's not picking the right, it's not slicing up all the floors. It's not really doing it properly, right? So when I select isotrim, it's just got this weird thing happening. So let's see what my data tree looks like at move, right? So you guys need to get into the habit of always understanding your data tree at every step of your project. Okay, so this is what my data tree looks like coming out of this. This is what my data tree looks like coming out of this. Right, and I'm using the geometries themselves to cut my domain. So what do you think I need to do here? See how there's like 3 levels of data in my domain, and there's 2 levels of data in my surfaces. Um, you could, well, the thing is, I want to retain my domain segmentation. So I want to match this data tree with this data tree. So maybe I can graft it. I can graft the move because what it will do is it'll create an extra layer. See, all of a sudden, here, I'll show you what happened. So my geometry, look, I have data with 3 branches. So each branch is for each building, and each branch has the number of floors. But my divide domain has 15 branches. But I know I'm doing the right thing because I'm using the surfaces themselves to divide the domain. So I have the right data tree structure there. So I need to add another layer of like a branch in here. Okay, another layer. So when I graphed it, see how now it's got data with 15 branches down here, but now it's also got data with 15 branches up here, right? So I'm matching the data. That's what I'm doing. Grafting is basically adding another layer. You're adding another layer of, for your list. So now when I plug in graph tree into surface, see how it's subdividing all my surfaces now. Does that make sense? I'm trying to match my list. Divide domain square. You have to use divide domain square. There's 2 divide domains. BREP. Okay. Here, just tell me if you're doing the right thing here. You've got the move command, and then from move, you're going into domain. and it's not reading it. Uh, how many items do you have going into merge that go into count in the series? Three. And then do you have this turned on? Display, draw fancy wires. Is it turned on or it is turned on? Are your lines dashed coming out of series or and then coming out of geometry are they dashed? And then you're sure you're using divide domain square. This one. Okay. Okay. Does everyone get up to this point? You want to have enough like stuff happening for your enough curvature on your curve. If you have too many control points, if it's like pinching, is your curve pinching upon itself? Yeah, so delete those or manipulate it back and you'll see it'll work. Good. So you break things and you learn things. I didn't even know that. Okay, so what do I need to do next in order to create my floor heights? What can I do to all these surfaces I have now? Yeah, correct. Correct, Mundo. Extrude. So I'm going to plug this into extrude, and then for direction, which direction do I need to go in? Yep. Uh-oh, too many surfaces. Whew. 2.8 seconds. Shit, too much. I am going to manipulate my U and V count. Okay, so I'm gonna come in here. So right now you can see U is 10, V is 10 by default. I want to reduce it, so I'll make sliders here. Copy the slider. Then for the first one, I'll make it maybe like 2. Second one, I'll make it like 6. Okay, but you see how the heights are not good. So what do I need? So for my Z, which heights need to come in there? Where will I get my heights from? So it can be parametric. What component in the series is affecting the height? Yes, very good. There you go. Now you have a building. So I'm going to hide my ISO trim, hide my graph tree, I'm going to hide my move, and then you have the extrude command, which is giving you all of your different floors. So now I want to be able to select um, like one item, one by one. Um, but before that, let's look at our data structure. Okay, let's try to understand our data structure. So the transformation that's happened, right? So we've gone extrude is this. Um, when we grafted it, we did this. So you see how grafted and extrude matches, right? This matches with this, which is what we want. It's very good. We have a consistent data stream happening. And then let's see at loft, what did we have? Param viewer at loft looked like this, okay? And then after move, param viewer looked like this. This is very good for you guys to like, if you make this part of your practice, you'll start, understanding these things more. So after move, it still looked like this. But when I divided my domain, it looked like this before coming into isotrim. So move and param viewer were not matching. So I made the match by using graph tree. So I made this and this match by grafting my geometry. When I grafted my geometry, it gave me this. And then that matched up, and it stayed at a consistent data structure after it's true. Does that make sense to everyone? See, even like if you could have done the same thing by copying and pasting a lot of these components, having a lot of like really big script, everything's being copied. But this is how you manage your data. If you can wrap your head around this, and it takes time. Sometimes when I haven't used Grasshopper in 6 months and I go back into it, I almost have to give myself a refresher. Just you have to stay on top of it. But yeah, if you can learn how to understand and work with data trees in Grasshopper, you will be the Grasshopper king or queen. At that point, you just need to know which components are available to you to do what you need to do. Okay, let's try to pick items from this. Okay, so let's go. I'm going to go tree item. Let's take our extrusion going into tree item. And then we want to construct a path, so we'll go construct path. Let's go maybe, I'll just make something random, 0 to 10. Copy it, go into indices, and then for index, I'll go 0 to 10. And it's not working. So path 0, 0 does not exist within this tree. But what if I add another one? Another one for path, and I also take that into indices. That works, right? So what I'm trying to do now, by using tree item, I'm trying to pick these, this like coordinates of the data. Do you guys get that? So this here, 0, 0, 0, is how I'm using this 0, 0, 0, and I can manipulate that. But inside of it, we have 12 items. So how you pick the 12 items inside each list is by using another number slider for index. Okay, and then let's visualize it. So let's open a panel. Let's put the extrusion into this panel, right? So it's got this list, and here you go. You can see up here, see? 0, 0, 0, and then here's your index. This index is this index. Okay, so I'm just constructing a navigation method to select from these items. So if I have 0, 0, 0, list number 0, 0, 0, item number 0, let's see what it's picking for me, this one. See? So 0, 0, 0 is my first building. So if we look at this, see this? 0, 0, 0, 0, 0, 1, 0, 1, 0. So all these zeros on my first building. And then I think these are, let's just see what it's. If I go, yeah, one, two, three, and then it's still picking from here. I can go up to, I can pick all the items on that floor. And if I want to come down to the next floor, let's see, I have to go with the last one. Yeah, so the third one contains, I have to go to 001, and that's my next floor up in my first building. Okay, and that's going to give me all these floors. But if I want to go to the next building, I move my middle slider. So I go one, and that takes me to my second building. And now I can pick from any floor in this building by manipulating my these middle two sliders. This is not doing anything. This row or this column is not doing anything. So what I could do here is, if I want to simplify this more, I just want to collapse that outermost one. What component do I use? We used it already. Very good. You guys are already experts. So let's put trim tree into this. But see how this is not working, because when I do trim tree and I put it into param viewer, now I've got three branches. See, now it's even more simple. Now I've got three branches, one for each building, because I just collapsed one entire branch. Now I've got three buildings, and each building has all my floors in it, all my rooms in it, 24, 96, 60, because I collapsed the one data structure. Now it's like this. It's simplified. Now I can pick from it. So in order to pick from it to build my tree item, I have to delete one thing, which is probably this last one. See? Now I have two number sliders for each of those coordinates, and inside of it, I can pick my floors. So I go up to all the way to 96. So I'll right click on my slider. I'll go range 96. Okay, and then now I can start picking my floors. See, and then if I go, I'm at 0, 1, but if I go 1, or no, sorry, 0, I stay at 0, 0, 1. I'm at my second building, 0, 0 will be my first building, and then 0, 2 will be my third building. Actually, let's see what simplify will do. Let's just see. I'm curious. Simplify. What is simplified tree? Okay, put this in. Simplify is still giving me, it's still going back to the 15 branches. Um, it's still going back to the 15 branches. So it's removing overlap shared amongst all branches. Okay, so let's just see. Trim tree reduces complexity of a tree by merging the outermost branch. So the outermost branch will get merged into its constituent list. But with simplify, it removes the overlap shared amongst the branches, so it's not really altering your list in any way. But trim tree is actually consolidating your list. So in our case, we continue to use trim tree. The more you use it, the more you'll understand, don't worry. But do you guys kind of get the gist of it in terms of how data trees work? Has Grasshopper become much more clearer today? It's still complex. This isn't, it takes time to wrap your head around it. It's not something you're gonna, just understand overnight. But if you can start to understand how you match data at a basic level to do what needs to be done in Grasshopper without having all these errors, you're already winning with Grasshopper. This exactly. Oh, you mean like if you had to do it in Rhino? See, this I'm just using buildings here as an example to show you. you would use this anywhere. Let's say if you're using Ladybug, for example, okay? Now you've got solar information from Ladybug, like hours on your building facade. Let's say, for example, you can use data matching to manipulate window size openings on your building facade using Ladybug information. Anything and everything that needs to be done in Grasshopper, you can do using data matching techniques. You basically need to understand how Grasshopper works, right? You understand how Rhino works. You press buttons and it does things. You can slice things, move things, etc., etc. It's the same thing. It's just a different language that we're speaking in Grasshopper. You're just trying to understand how it works so you can use it. Anyone have any questions? Okay. Good job, guys. Good job.